Alright, in this video we'll look at how to work out the standard deviation for a set of data. We've looked at the range and interquartile range before, and as I've told you, both the range and interquartile range only use two values, the max and the min for the range, and Q1 and Q3 for the interquartile range. This technique, the standard deviation, works out the deviation of every single score from the mean. So in this example we have these 5 values and they have been written up in our table here. The mean of those 5 values has been worked out to be 6. So the deviation from 6, we take away 6 from 2, we get -4. Take away 6 from 3, we get -3, and so on. So all of these values here are the deviation of all the x values from the mean. You'll notice that some of the deviations are negative because these values here, they are below the mean, whereas these values here are above the mean, therefore the deviation is positive. Now, if you were to work out the average deviation, what you'd do is you'd take the deviations here, add them all up, and divide by how many scores you have, as you would for the mean. But if I add up these deviations, the positive ones make 8, the negative ones make -8, we get a 0 overall deviation. So this will not work. So what we have to do is get rid of these negative values, and to do that I can square my deviations. So here I have squared each of my deviations, so -4 squared, -3 squared is here, and then if I add up the squared deviations, I get a total of 60. I then divide that by how many scores I have, 5, so I end up with 12. Now, that is not the deviation, or the average deviation, because I've squared these numbers. So therefore I have to square root that answer to bring it back to the relative size it should be, which is what we can see up here. So 3.46, or the square root of 12, is known as the standard deviation. Now, our book, the OSO 9, does give this formula here, which I do not agree with, because if you have a population, if you know every single score, then you divide by how many scores you've got. But if you've got a sample, like it says here, then the actual formula is modified, and you don't divide by the number of scores, you divide by n take 1. So, the formula is based on the fact that we work out the deviation, so take away the mean from each score, we then square it to get rid of the negative values, we then add them all up, and then we divide by, if we've got the population, we divide by n, the number of scores. If we've got a sample, we divide by n take 1. And then we take the square root of all those values to undo the fact that we've squared it. So in this example here, we've got numbers 12 through to 16. I first need to work out what the mean is equal to. So x bar is going to be the sum of the ages, all these ages here. The total is 68, and we've got 5 scores there. So the mean is equal to 1 left over. We've got 3 left over, so 0.6. Okay, so now I need to subtract the mean from each of the values of x here. So we end up with -1.6. We've got -0.6 here. 13 take, okay, again, -0.6. 14 take 13.6 is 0.4. 16 take, I end up with, what's that, 2.4. If I were to add the deviations here, I get 2.8. If I add these negative deviations, what's that? That's 0.12. 1.2 is 2.8. I get positive and negative 2.8, I get 0. So I can't add the deviations, I need to square them. So if I square 1.6 or -1.6, I get 2.56. Square the -0.6, I will get what's that, 36, so 3.6, no, 0.36. 0.4 squared would be 0.16, and 2.4 squared would be... So these are the squares of the deviation, so I now need to add up the squares of the deviation. So let me do that. So deviation, the squared deviation sum is 9.2, and therefore my standard deviation. Now the symbol for standard deviation is one of two symbols. We either use lowercase sigma or we use s. Now lowercase sigma is the symbol we use if we've got the population, and s we use if we've got the sample. So in this case, if we stick to what the book has been doing, they're treating it as if we have got the population. So that data there may be all the data. There's no more data that we are approximating for. So we'll stick with the sigma for this one. So therefore, my value of sigma is equal to the square root of, we've got 9.2 is the sum of the squared deviations, divided by n if we've got a population, and there are 5 numbers there. So working out the square root of 9.2 on 5, we end up with a value of 1.36. In the next video, I'll show how to use the graphing calculator to calculate the values in this table using lists in stats mode.